Hello everyone, welcome to my YouTube channel. In this video I am going to show how to analyze and design a G+6 Storey building using STAAD Pro software including seismic analysis. Here you can see the grid plan of this building, and here you can see the elevation of that building, and here PL at 0.6 meter height and depth of foundation here 2 meter. And here we are using M25 grade of concrete and Fe415 grade of steel, and also I am using here live load, which is 3 kilonewton per meter square, because this is a residential building, so that's why we are taking live load as a 3 kilonewton per meter square. Now I am going to open STAAD Pro software. I am using STAAD Pro version 8 and series is 5, so you can use also higher version, no problem with that. So now I'm going to start a new project here. So click on new project, and here I'm going to select space because we are going to model a RCC frame structure, so that's why I'm going to select space here and give the file name here, say G+6, and now you have to select the location at which location you want to save this file. So now I have selected the location, and now by default unit I am selecting here meter for length, and for force I am going to select kilonewton unit here. Then click on next. Now discuss about the user interface of STAAD Pro software. So first, here you can see these are the menu words, and here you can see these are the tools which will be used to design, which will be used to model, analysis and design the structure. And here you can see also some tools are there, and here you can see some tabs, and here also you can see some tabs. I will discuss them in details when I will be use them in this project. So here you can see this is the workspace. So whatever model we will draw here, that can be view here. And now let's begin. So first I am going to close this grid table, and now I'm going to click on first this setup tab, and here you can write the project details here. I mean, like project name, client information, date, and also the project number, etc. All the details you can write here. So here I'm not going to write anything. So now I'm going to next tab, that is geometry. So now I'm going to click on geometry. So when you will click on geometry, this grid will come again. So now I'm closing this, and now first we have to model the structure here, right? So now I'm going to see the plan of this structure. So here you can see this is the grid plan of this structure. So first, when you will model any kind of structure, any kind of building in your STAAD software, so first you have to draw the grid plan of that building. So here you can see this is the grid plan of this building, and here one more thing, first you have to know the coordinate system. So here in STAAD Pro software, STAAD Pro use the Cartesian coordinate system, and here you can see y is vertical and x z in horizontal plane. So whatever plan we will model or draw here, that will be in xz plane. I am going to model or draw whole building in positive side. I'm not going to draw anything in negative axis. That's why I'm going to naming the nodes number like this. Suppose this is node number 1, this is node number 2, this is node number 3, like this. And the coordinate of node number 1 is 0 0 0. It's meaning first we are going to draw the node at foundation level. Now first I'm going to draw the node number 1. To draw the node number 1, first you have to click on geometry tab, and now I'm going to close this, and here you can see these are the nodes table, and here you can see these are the beams table. So in nodes table, here you can see this is the node number 1, and just write here 0. Okay, so if I write here 0, it's mean at 0 0 0 coordinate a node is created, the node number is 1. So here you cannot see any node number, right? So if you want to turn on the node number, you have to click on this symbols and label tool, and here first you have to be sure that you are under labels tab, and here under this nodes group, here you have to turn on node number. Okay, or there is a shortcut you can use, that is shift plus the letter shown in bracket. So here the letter shown in bracket is n, so that's why you can directly use the shortcut key, that is shift plus n. And now I'm going to click on OK, and now here you can see the node number 1. And now we have to draw node number 2, node number 3, like that up to node number 5. So how can we do that? So for that, here you can see the spacing of the nodes is like, so first node is the second nodes is spacing at a 4 meter, then up to fourth node the spacing is 4 meter, but for fifth node here the spacing is 5 meter. So that's why what I have to do, I have to repeat this node in x direction. Here you can see we're going to draw it in x direction, right? So that's why we have to repeat this node in x direction. How many times? 4 times. So to repeat the nodes, so first what we have to do, we have to select the nodes. So to select the nodes, you have to turn on node cursor, that is available in this tool. So this tool name is selection tool. This is available, you can see here it is available. So here just click on node cursor. Okay, so this is the node cursor. Now I'm going to select this node. This is the node I have selected. Okay, now I will click on geometry menu bar, and there I will select translation repeat. This option also available here in this tool, it is available. So the name of this toolbar is generate. Okay, so in generate toolbar it's also available, so you can use it here. So now I'm going to click on this translation repeat. So when you will turn on this, be sure the node is selected. Okay, so here I have selected the node. Now I want to repeat this in x direction, so that's why in global direction section I'm going to select its x. Okay, and how many steps there will be? It will be 4 times, right? So that's why I'm going to write here 4, and here default spacing, since the maximum number of spacing is 4 meters, so that's why in default step spacing I'm going to write here 4. So sometimes this pop-up window will open, so here it's asking to save the file, so you will just click on yes and save it. And now here default spacing I'm writing it's 4, so that's why all the spacing here you can see 4. So but the last node spacing will not be 4, as per diagram here you can see the last node spacing is 5 meter, so that's why I'm going to write here 5. And now I'm going to, all is okay here. Now I'm going to click on OK, and now here you can see the total number, total 5 nodes it is created. So just I want to sure that all the spacing is okay or not, so that's why you can use this tool. This is called display node to node distance. So just turn on this tool and select this to node, just click here. So here you can see this spacing is 4 meter, this spacing also is 4 meter, this spacing is 4 meter, and this spacing is 5 meter. So if you want to remove this dimension, just click on this remove all node to node distance display. So now here you can see this is the isometric view, and if you want to change the view, suppose if you want to see the plan, then you can use this tool. This is called rotate tool toolbar. So here you have to select this tool that is called view from plus y. So if you click on that, so here you can see the see this node from y-axis from plus y point, right? So that's why it's you can see the plan. Okay, and now I'm going to generate all others nodes, like the same nodes I have to repeat in z direction. So here you can see in z direction I have to repeat it, and how many times? 1 2 3 4 times I have to repeat. And here the spacing is, first one is 4 meter, then 5 meter, then 6 meter. So that's why what I have to do, first I have to follow the same method. So first I am going to select all the nodes here, then I am going to click on translation repeat, and here in global direction I have to select it z direction because I want to repeat in z direction, right? So here it will be how many times? It will be 1 2 3 4 times. So now 4 times I am going to repeat it, and here the spacing will be like, first spacing will be 4 meter, and here default spacing I'm keeping it 5 meter because the maximum number of spacing is here 5. So that's why here I'm going to change this, it is 4 meter, and the last one will be 6 meter. So that's why I'm going to change it 6 meter. And now I'm going to click on OK, and now you can see all the nodes is created. And if you want to see what the distance is okay or not, so you can check it. So I'm checking it. So far the first distance is 4 meter, then next one is 5 meter, next one is 5 meter, and last one is 6 meter. So it's okay. So now I have created all the nodes at foundation level. Then I have to draw the nodes at plinth level because I'm also going to provide the beam at plinth level. So actually I have to create a node at those level where I want to add some structural member. Here only I am going to add only beam and column as a structural member. Here I'm not going to add any slab or any wall here. Just I am going to model only beam and column here. So since beam and column is a line element and also line element, I have only two nodes. So that's why I have to create the nodes at each level where I am going to add beams and column, right? So that's why I have to uh, repeat these nodes at plinth level, at first floor level, and up to roof level. So that's why what I'm going to do, I'm going to click on then again node cursor, then I'm going to select all these nodes, and then I'm going to click on translation repeat. And now this time I'm going to repeat in y direction because y axis is vertical. And here how many times? See, we have drawn all the nodes at foundation level, and this is the plinth level, so, and this is the first floor level, and this is the roof. So it will be like 1 2 3 4 5 6 7 8. How it is coming 8? Actually, it's a G+6 story building, so 6 story are there, and one is roof, that is 7, and one at plinth level beam. So that's why it is coming total 8. So one I have done at foundation level, then I have to repeat it 8 times. But here one thing you have to notice, that is the height. Height is different for each floor level. Like different mean, the floor to floor height is suppose here I am assuming it is 3 meter, but for plinth level beam this height will not be 3 meter because here I am assuming that the plinth level at 0.6 meter from ground level, and the depth of the foundation is 2 meter. So then the total height from foundation to PL will be, it is 2.6. So when I will repeat it for plinth level, or that time the height will be, the spacing will be 2.6 meter, and rest other floor, for rest other floor it will be 3 meter. So that's why what I'm going to do. So here I'm going to repeat it 8 times. So here the steps will be 8 and default spacing will be here 3 meter, and for fast spacing it will be 2.6 meter. Here one another thing I will turn on, that is called link step. So this checkbox I will turn on. Why? Because actually what I want to do, when I will repeat this node at different floor level, same time also the I want to draw the column line element, because if I turn on this link step, what will happen when it will repeat this step from one level to another level, that time it will link these two steps, I mean these steps with an element. So that's why I'm going to turn on this link step, and now I'm going to click on OK, and let's see what happened. Here all the nodes have created. So if you want to see in 3D render view, so just click on this 3D rendered view tool, and here you can see all the column member is created, and also all the nodes is created. Or you can see here the isometric view. So just click on isometric view here, and here you can see all the column member is created. Now I am going to draw the plinth level beam. So here you can see we have to draw this beam in plinth level, first floor level, second floor level up to roof level. So that's why what I'm going to do, to draw the beam member, I'm going to use this tool. This is called add beam tools, or this tools also available in menu bar. You can click on geometry, then go to add beam, then select this add beam from point to point. So if you use this beam tool, so what you have to do, just you have to select the start node and end node of a beam, then automatically a beam will be created like that, like this. So I'm going to delete this, and now first I'm going to draw the beam at plinth level. So you can see this is the plinth level node, but from this view you cannot select the plinth level nodes, right? So that's why we need a proper view so that we can draw the beam at plinth level. So that's why what I'm going to do, I'm going to click on view. So before that, first I'm going to select the nodes. So what you have to do, first you have to change the view. So I want to see the elevation of this structure, so that's why I'm going to click on -x or whatever. You can select also -z or +z, whatever. So I'm going to select +z here. Now select node cursor, now select the nodes here, and now click on view, then select view selected object only. And now here if you select this option, then what will happen, only whatever node or element you will select, only those element will be visible uh, in your workspace. So what I'm going to do, I'm going to see the top view. So this is the top view. So here we can see the plinth level beam, and now if you use this tool you can easily draw the beam here. So now first I'm going to draw the beam along x direction only for this portion, and now I'm going to close this tool. Now you can click here or you can skip button. So now I have drawn this beam. Okay, now I have to repeat this beam along z direction how many times, 1 2 3 4 times. So I have to repeat this beam along z direction. So that's why first I'm going to select this beam. So to select the beam you have to click on beam cursor, then you have to select the beams here, then you have to click on translation repeat, and then I want to repeat it in global Z direction. So now I'm selecting here Z, and now this is 4 times, and here this spacing will be 4, and this spacing will be 6 as per our diagram. Here you can see, so this is spacing is 4, this is 5, this is 5, this is 6, so that's why it will be like that. And here one option we will turn on, that is called link step, because if I turn on this option here, what will happen when I will repeat this in Z direction, also the beam along Z direction will be automatically created. So that's why I'm going to turn on this, and now I'm going to click on OK. And now see here, all the beam in plinth level have been created. So if you see the render view, it is clearly visible here. And now next what I'm going to do, now I'm going to repeat the plinth level beam in first floor, second floor, like that up to roof. So that's why what I'm going to do, I'm going to select all these beams. So that's why just click on beam cursor and select all the beam here, then click on translation repeat, and this repeat I want to done in y direction. And here what will be the spacing and how many times it will be. See, I have drawn the beam at first at plinth level, and now I have to draw the beam from first floor to roof, so that's why it will be 7 times. So that's why what I have to do, I'll write here 7. And what will be the default spacing here? Default spacing will be a 3, and that's all. Here I will not turn on link step because I already have created the column member, so that's why I'm not going to turn on this. And now I'm going to click on OK, and I think all the column member have created. If you click on this render view, it is clearly visible, all the column member is created. And now here I'm going to select the isometric view. Now here you cannot see the whole structure because only those elements are visible which was selected, right? So that's why if you want to see the whole structure view, then click on view, then click here whole structure, or you can directly use it from here. And now you can see the whole structure. Okay, so this is how you can model any kind of structure, that may be a building, that may be a bridge, or any kind of structure. And now here one important thing is that here we haven't add any member properties. Here only we have defined the beam elements node number. I mean, we just define the start and end node of each and every element, but we haven't defined any properties like what is the size of this member, what is the material properties, like it is the material is concrete or steel, etc, etc. These all material properties and section properties we haven't added yet, so we have to add those things. So now I'm coming to that point. Now I'm going to assign section properties here. Here we are going to model a G+6 story building, so that's why we are going to assume the preliminary size of the section like this. Up to third floor, the beam size along shorter direction is 500 by 300, and along longer direction it is 550 by 300. And also column size is 600 by 500 up to third floor level. And fourth floor to roof, the beam dimension is like that. Along shorter direction it is 420 by 250, and along longer direction it is 450 by 280, and the column size is 500 by 450. So now I'm going to add this section in I'm going to add this section here. So to add the section here, you can click on general tab, okay, or you can directly go to access here, like member properties and prismatic, like that. Same you can use also this, or you can just click on this general tab, and here this window will be open. Here you can access this, and here you have to click on this define tab. And now we are going to add rectangle section, so that's why I'm going to click on rectangle. And here you can see here YD is the depth and ZD is the width. So now here you can provide the section dimension here, but one more thing is important here, that is the local coordinate system and global coordinate system. So you have to know that what is local and global coordinate system. I already made a video on that topic. You can watch that video. You can click on this ice button, and this video is available in my channel. I'm sure that after watching that video you will not have any doubt about local axis and global axis. In simple word, the origin of the global coordinate is fixed. It is same for all the elements, but the origin of local coordinate system is not fixed. It is depend on the element. And the direction of the global axis is fixed for all member, but the direction of the local coordinate axis is not fixed for all member. It is depend on the member orientation. So here you can see this x, y, z are the global axis, and this x, y, z are the local axis, and the origin of this local coordinate system at the center of this member. So in STAAD Pro software, the x-axis always directed along the longitudinal direction of the member, and y-axis will be along the direction of the depth of the member if the member is parallel to x-axis and z-axis, and the z-axis will be along the width of the member if the member is parallel to x and z-axis. So here you can see we are going to add the section dimension for beam member. It's horizontal member. It's mean the beam member are parallel to x-axis or z-axis. So that's why here I'm going to write the depth of the member along y-axis. It's mean here I'm going to write the depth of the member. So now here I'm going to write this up to third floor. The in shorter direction the beam size is 500 by 300. So that's why I'm going to write here depth is 500. It's mean 0.5 meter, and it is 0.3 meter. I'm going to add this, and here I'm going to select the material as concrete because okay. Now next, along longer direction the section dimension is 550, width is 300. So now I'm going to add it, and for fourth floor to roof the dimension is 420 by 250, so it will be 420 by 220 by 250, and this will be 450 by 280. Okay, so now I have added the beam section here. Now I have to add the column section here. Before adding column member here, first I'm going to check the orientation of column member here, because here the column dimension is 600 by 500. So this 600 dimension should be along the longer span, and this 500 dimension should be along the shorter span. So that's why I have to place the column member so that the along longer direction the column dimension should be 600. So that's why what I'm going to do, first I'm going to check what is the column orientation in my model. So that's why now currently I'm going to close this, and now first I'm going to select the all column member here. So select column member here, then beam parallel to y-axis. So column member all are parallel to y-axis. Here it is written beams because here all element considered as a beam. that may be horizontal member, that may be vertical member, that doesn't matter. Here all members are called beams, so that's why here it is written beams parallel to. So but beam parallel to along y, that's mean it's column member. So now I'm going to select it, and here now I'm going to click on view selected object only, and here you can see only the column member. And now I'm going to turn on the local axis orientation for column member. So you have to click on the symbols and labels. Here I'm going to turn off the note number because because of this it is too much congested. So that's why I'm going to turn off this, and I'm going to turn on this beam orientation option. The shortcut is Shift plus O. You can directly press Shift plus O, so automatically beam orientation will be turned on. So now I'm going to click on this, and now click on apply. Now okay, then here you can see the column member orientation. So here the when we have uh, created this column member, that time we have we have conduct translation repeat comment, right? So that's why, and the repeat was it repeat have been done along y-axis, and always it is from from foundation level to roof. So that's why all the column member are directed from bottom to top. That's why you can see the direction of the column member in upward direction. And here this blue axis is the x-axis. This is along the longitudinal axis, and here y-axis, the red color axis is the y-axis, and green color axis is the z-axis. So y-axis always in the direction of x, and z-axis in the direction of z. So now we have seen the column member orientation here, and now what I have to do, now I'm going to add the column section here. So now I'm going to click on again general, and now in this window I'm going to click on define, and now I'm going to select rectangle. So now here you can see this YD, actually this red axis. Okay, so now in our we see in our grid plan, so in this grid plan longer axis in which direction it is. So here you can see this total length is 4 meter 4 meter, that is this total distance is 17 meter, but along this distance is 20 meters. So this is the longer direction. So the column orientation should be that the 600, the dimension, I mean 600 side dimension should be along the longer direction, right? So here longer direction along z-axis. So here you can see that along z-axis we are getting the longer direction. So that's why what I'm going to do, along z-axis mean here also it is in z-axis, because this green axis along the z-axis. So along z-axis this dimension will be 0.6, and along shorter direction it will be 0.5. So that's why here YD will be 0.5 and ZD will be 0.6. Now I'm going to add this material, I'm going to add this section. Now again another section is 500 by 450, so also this will be 500 and this will be 450, and now I'm going to click on add. Now all the sections I have added here. Now I have to assign this section on beam and column member. So that's why so before assigning, what I'm going to do, I'm going to make some groups so that that will help me to select the member. So now I'm going to turn off this beam orientation here. Now click on apply, then okay, here we're seeing only the column member. Now click on the whole structure. So here we can see the whole structure, and now we're going to form some group. To form group, click on this tool and create new group. So first I'm going to form the group for beam along x direction up to third floor, and now here select type, I am going to select beam, it's beam. then click on OK. Now one group I have created, and now I'm going to create another group, that is beam z direction up to third floor. So here one thing you have to keep in mind, that in the name you cannot use any blank space. Okay, so that's yeah. Now here I'm going to select beam type, beam select type, then okay. Now second group is created. Now I'm going to create another group, that is beam along x direction up to 6th floor level, I mean 4th to 6th floor level. And now I'm going to create another group, that is beam along z direction up to 6th floor, and here select it is beam, then okay. And now I'm going to create column member, column up to 3rd floor, and I'm going to create again column member up to 6th floor, I mean roof. And now I'm going to create some floor group, like for first floor beam I'm going to create an floor. So this is, I'm naming it first floor. So here the select type will be floor, and now I'm going to create another floor, that it's second floor, then here it is floor, then it's okay. Similarly I'm going to create a floor level up to roof, I mean next will be uh, 3rd floor. Here you have to select this is floor, then 4th floor, so these are all the floor group I have created. Now I have to assign one by one all of this. So first, now I'm going to select the beams along x direction up to 3rd floor. So that's what I'm going to do. So first I'm going to see the beam up to 3rd floor level. This is plinth level, this is 1st floor, 2nd floor, 3rd floor, this 4th, this is 5th. So up to this I'm going to select. First you have to select the beam cursor, then I have to select all the beam. Okay, so just select the beams member here, press Ctrl button and select all the beam member here like this. And now what you have to do, you have to now click on this view, then you have to select the view selected object only, and now what you have to do, so if you see the isometric view here, you can see only the beams up to 3rd floor. And now I'm going to click on select, then I'm going to select beam parallel to x direction. So now here the beams along x direction up to 3rd floor is selected. So now I'm going to select this option, and now here I'm going to click on this associate tab. And first of all you have to be sure that this option is selected, then click on this. And now here you can see the beam have assigned, okay, for this group. And now similarly for a z direction beam, I'm going to first select them. This is the z direction beam. Now I'm going to select this, then I'm going to associate this. Okay, now the beam are associated. Similarly, and again I'm going to sing the whole structure again for this. This is 4th floor, 5th floor, 6th floor and roof, right? So now I'm going to select them first, This is fourth, fifth, sixth and roof. Then view selected object only, then see the isometric view, then view selected beam parallel to x-axis. This is associate, and then select along z-axis, this z, then associate. Then what you have to do, again I have to select the column member here. Now coming to the whole structure, and now again I'm going to select, this is first floor, second floor, third floor, fourth floor, so I'm going to select up to here, and now view selected object, go to the isometric view, and here select beam parallel to y-axis. Now select this, now associate this. Similarly I have to assign, now come to the whole structure, and now you have to go to the elevation part, and now here I'm going to select this portion. This is fourth floor, fifth floor, sixth floor. So now view selected object, and now here select parallel to y direction, then this select column 6, then associate this. And now I have to assign the floor group. To assign the floor group, so you have to select the each floor here. So first I'm going to see the whole structure, and now this is the first floor beam, so the select the first floor beam and select the first floor here, and then associate. Similarly for second floor, and finally this is for roof. So now you can check all the assign is correct or not. So first click here, then click on this highlight. See, beam along x direction up to third floor level is selected. Now beam along z direction is selected. Now beam up to sixth floor along x direction is selected. Z direction is selected. Column are selected. Then first floor beam is highlighted. Second floor beam is highlighted. Third floor beam is highlighted. Fourth floor beam is highlighted. Then fifth floor. Then sixth floor, and then finally roof. So all the assignment is correct here. So this will help me to select the member easily. Okay, so now I'm going to click, I'm just going to close this. Now I'm going to assign this member. So now I'm going to click on select, then I'm going to select member by group name. So just click on this window will be open, and here first I'm going to assign beam along x direction up to third floor. So now select this. Now here you can see the beams along x direction up to third floor is selected. Now I'm going to click on this general tab, and now here, so this is the, for this section is for beam along x direction up to third floor. Here you can see uh, along x direction is the shorter direction, so that's why up to third floor the dimension is this. So this is the section. So now here this beam again unselected, so that's why I'm going to select it again, then select this by group name, select this. Okay, now click on here assign, and be sure that here assign to selected beam is turned on, then click on this assign. Now click on yes. Now here you can see this R1 section is assigned for all this beam, and now select this, then this is deselect this, just click on this. Now we have selected the beam along z direction. So now select this option. So first select this option, then turn on this. Now click on again assign. Now I'm going to select I'm going to assign the beam along x-axis up to roof. So here I'm going to select this, uncheck this. Now click on assign. Now I'm going to select beam along z direction. Going to assign, and now I'm going to assign the column member here. Now I'm going to assign column member up to roof. Okay, so now I'm going to close this, and now I'm going to check whether all the assignment is correct or not. So now click on this 3D render view here. You can see I haven't add any column member here. This is because of my selection problem. So what is happened here? See, this is plinth level, this is first floor, this is second floor, this is third floor. Okay, but this floor column I haven't selected, so that's why here you can see you cannot see any member here. So that's why what I'm going to do, I'm going to edit this selection. So that's why I'm going to that's group name again here, and now here I have to modify this. Here it is. So for this I'm going to select the elevation, and here see, this is the plinth level beam, this is first floor, this is second floor, this is third floor. So I have to select these all the columns here. So now first I'm going to select view selected object only here. Now then I'm going to select beam parallel to y-axis. Now here all the column member is selected. Now I'm going to associate this. Okay, now I think this is the correct selection again, and now I'm going to assign them again. So now what I'm going to do, first to select by group name here, and now I'm going to select this, and now I'm going to assign. Now I'm going to check this. So first see the whole structure here, and now check it here. Now here you can see all the member is correctly assigned, and here you can see because of this section name, this is too much congested, so you can remove them. If you want to remove this section name, then click on just geometry, it will be automatically removed. Okay, now I'm going to add support specification here. So I have to provide support at foundation level. So first you have to select the node cursor, then select all the nodes here. So now I have selected all the node at foundation level, and now I will click on comment, then I will go to support specification, then I will select fixed, and here in this table you can see it is selected on fixed, and just click on this assign, and now here you can see support 2 is added, that is the fixed support, and it is assigned to 1 to 25 node number. Now close it here. So here you can see the fixed support is added in foundation level. So now the model is ready. Only we have assigned the material properties, section properties, and support specification here. We haven't add any load condition here. So in next video I have covered the loading part and analysis part. So watch the next video for loading and analysis part. Thank you for watching. If you like this video, subscribe my channel and share this video to others.